Hello everyone, dear friends. Nikita is here with you again. And I welcome you to our next lesson dedicated to surgical guides in the RealGuide program, our updated course on this software. And today we will be discussing full arch cases on Edentulous jaws. We will go over the algorithm that we use ourselves when making surgical guides, talk about matching an Edentulous jaw with a CT scan, how to plan guides, and share various tips and life hacks. In short, it's going to be interesting. Also, if you are interested in in-person training on this topic, you can check out the link in the description. So I hope you'll find it interesting, dear friends. All right, after taking a brief short break, we'll be continuing shortly. So, as I mentioned in the previous steps, there are cases where we don't need a CT scan right from the start. This is really a matter of algorithms. I want to say that right away. And for now, you can just blindly follow along with me. Later on, when we start working in the software, I'll explain our approach, how we work with Edentulous jaws, because that's important. It's not just the technical skill of using the software and doing everything correctly, like placing things the right way. That matters. It's also important to understand the algorithm itself, meaning the clinical workflow, what comes after what, and what is needed at each step. Without this understanding, you won't get anywhere. But as I said, for now, just follow along with me. And as I mentioned, I think in the first Lesson Ani project in the RealGuide, for me and for all of you as well, is connected to computed tomography. In other words, to start any project in RealGuide, you need a CT scan. That's why I've already clicked on the plus sign, entered the patient's name, and now I'm selecting a folder. This is my folder here, and I click on select folder. Right now, in this case, I will repeat, it doesn't matter at all which CT scan you have, because for our current purposes, it really doesn't matter. We're only doing this in order to launch the project in RealGuide. So while I'm talking here, my project is loading. All right, it's loaded. Now, let's open it. It's called Edentulous lesson. It just needs a moment to render, and then I'll open the program. All right, the CT scan has loaded, the program is open, and as I mentioned, we won't be focusing on this CT scan right now. We're not going to waste time correcting noise or anything like that. And if you don't have this patient's CT scan, it doesn't matter. You can use any other CT scan, regardless of whether it's from another patient or this patient, it doesn't matter. I'll repeat, this is just a technical step right now, you could say, to trick the program, because the program links itself to the CT scan. In any case, I've just clicked through 2 steps to reach the data import stage. So now we're going to import data into the project. There you go. And we have a scan of an Edentulous jaw, which we're going to upload as the anatomy. Here in my folder, I have this anatomy file. So now I'm uploading it. As we can see, it's basically this kind of file. So this is a scan of an Edentulous jaw. And since this is the first file we've loaded into the program, RealGuide immediately suggests that we align it. We won't be doing that right now, so we click Apply. Well, here it's already aligned for me because I probably worked with this object before, and in the 3D format, this file, specifically in the operating system, the file's coordinates were saved. Now, just to keep things fair, I'll move it back on purpose, and then we click Next Step. Well, here, yes. The CPR plane needs to be constructed, basically, again, just so that the program works correctly, because otherwise there's nothing you can do about it. That is most likely the next steps won't work properly if you don't create at least some kind of CPR plane. But I'll repeat, as you can see, I've deliberately turned off the computed tomography, don't need it. In fact, right now we're working only with the scan. Most likely, if you take the scan you need for the right patient and someone else's computed tomography, just like I took someone else's CT scan, you'll probably end up in the same situation as I am now. That is, your scan will be slightly offset from your computed tomography, but this is only temporary. And now we have this kind of scan. We click next. Right now we're not going to place any implant, so we immediately click on Guide Design. Guide Design, because dear friends, we are now approaching the most interesting part, namely the so-called radiopaque guides, radiopaque guides which we are about to learn how to make together. So, what exactly is that? A radiopaque guide, let me say right away, let's first talk about the overall process. The thing is, a lot of colleagues, not that they argue with us, but they suggest different approaches. And during courses, people come and ask, can you do it this way? Can you do it that way? Can you do it another way? I want to say right away, the best method is the one that works in your hands. If you have perfected a method, say, for aligning an edentulous jaw with a scan, by all means use it if you are truly confident in its effectiveness. The method that we are about to demonstrate, the one that will be shown now, was developed well by me in particular, and we have further refined it within our team at Navitomia. So essentially, the method consists of making a special radiopaque template for an edentulous jaw, or if there are 4 or fewer teeth, or if there is a metal ceramic bridge with a lot of artifacts. I actually brought it here. Here it is. I hope it will focus now. This is roughly what it looks like. In fact, it's a kind of overlay for an edentulous jaw. So what would I like to say about this? We use a special sort of principle, since we are now going to make this template based on the shape of the edentulous jaw. The inner surface of this radiopaque template will replicate the outer contour of the mucosa. This will be very useful to us in the subsequent stages when we need to align one with the other. That's the first point. And the second important point to note is that this radiopaque template, which I showed you earlier, is actually going to serve as the future prototype of the surgical guide that we will eventually use in the oral cavity. What does this mean? It means that if for some reason during the CT scan, and this does happen at the stage of performing the CT scan, the radiopaque template does not fit in the oral cavity or fits incorrectly, well, on the one hand, that's quite bad because you'll have to redo everything, but on the other hand, the glass is half full, and that's actually very good because it's better for the template not to fit at the CT stage than for you to have already placed the implants and then realize that they ended up crooked. That's why this thing serves 2 functions. First, it aligns and creates special radiopaque markers on the edentulous jaw. And second, it acts as a prototype for the future surgical guide. In other words, we double-check the fit of the future surgical guide. Since this thing that is the radiopaque template is the prototype of the future surgical guide, it is very important during the CT scan not to think of it as a complete, removable plate denture. That is, you can't glue anything here, like flowable composite, Corega, or bite silicone to make it stay in place. This surgical guide, especially if it's for the upper jaw, will not stay in place on its own. It needs to be held either with a bite block during the CT scan or by the opposing teeth or by placing wax rims. In general, in the 21st century, we can come up with something to press this guide against the mucosa. Since I've already started talking about this, let me explain the rules for performing a CT scan with this guide. I'll go over this again once we've actually made it, but still. First, the guide should not be coated with anything on the inside because that would affect how it fits against the mucosa, and it's very important for us that the 2 contours match. Second, remember that this is a prototype of the future surgical guide. And third, this thing needs to have a repeatable position. When we place the guide on the edentulous ridge, even though it's toothless, believe me, it fits quite tightly, firmly, and it shouldn't move anywhere. This is important, but to make sure it doesn't move or shift, we now need to create a special feature for this in the RealGuide. So we've talked about radiopaque guides. Yes, one more important point. Of course, it's clear that in your clinic you might have, say, an intraoral scan, or for example, someone applies composite, places orthodontic screws, someone else makes holes in a plastic prosthesis and also applies composite to them, then scans. You can do it however you like, but I'll repeat, we do every case this way. That's the first point. And the second point is that it's quite convenient from a logistical point of view, because it doesn't matter whether you have a scan, whether you don't have a scan in the clinic, whether you have impressions. Well, everyone has impressions. Basically, all you really need is an impression, and that's it. And a plaster model. So it doesn't matter whether you have a CT scanner in your clinic or not. You can give this to the patient. The patient will take it, go get a CT scan, and basically everything will work out for everyone. This method has stood the test of time, and that's exactly what we're talking about now. Excellent. So now look, we have an edentulous jaw. This thing that I'm rotating right now, this arrow, is called the path of insertion. Accordingly, this is the path along which the guide will fit onto the jaw. So what's the main point here? This thing here, these blue sort of blue markers, or what we call them, areas, these are undercuts, meaning the program drops a perpendicular from them. We talked about this a little earlier, but it wouldn't hurt to repeat it now as well. So accordingly, what we need to achieve is we need to make sure that there are as few undercuts as possible, like for example right now. So what would be a bad situation? For instance, you see everything looks fine from the palatal side, but on the vestibular side there are some issues. In other words, the most optimal option is to have a minimum number of undercuts. And why is that? Because the contact area with the model is important for you. That is, the more your template is in contact with your model, the less likely it is to shift or move. Okay? Now, once we've chosen the path of insertion, we click Generate Undercut. And accordingly, as I mentioned, in these areas, this zone sits as if a perpendicular has dropped down from these, the areas that are marked in blue. Another important point, please pay attention to these edentulous jaws. It's not obvious to everyone, even for our colleagues we work with, and maybe you've encountered this problem too, that the mucosa can change its configuration. It's not as static a structure as, for example, tooth tissue, because a tooth, if it's intact and there are no issues, can go for years without changing its shape or position. Everything stays fine with it. With the mucosa, it's a bit different. And sometimes, for example, after surgery or during surgery, teeth are extracted and an impression is taken right away for a radiopaque template, or a scan is done immediately. And in this case, naturally, a socket forms a tooth socket, and the mucosa in the area of the extracted tooth will change its shape every day over the course of 2 to 3 weeks. If the mucosa in the area of the extracted tooth keeps changing its shape, then the contour, the inner contour of the template will already be outdated. Because if we don't pay attention to this and make the template based on what we see at that particular moment in time, let's say we make the template, but by the time it's ready, the mucosa has already changed, and this can lead to the template not fitting properly. For some colleagues, unfortunately, it's not obvious that the mucosa changes its shape after tooth extraction. But what we need to catch that moment in time when the mucosa is stable, meaning that the contour is stable and doesn't change, at least during the period we've set aside before the surgery. That's why, for example, here we see some questionable areas, because these kinds of dips in the mucosal contour generally resemble a socket that will most likely heal over. So similar to working with a plaster model where we had bubbles, we can click the plus tool that is add. I'll make it a little smaller now, and then accordingly I'll locally fill in these areas that make me unsure whether teeth were actually extracted there or not. These areas just look too much like extraction sockets of removed teeth. And then basically I continue examining this model as well. Overall, I'm satisfied with everything. I click next step. After that, that's eyewear basically ready for production, so to speak, for modeling the templates. I want to say right away, or rather, I'll repeat myself, this is not a plate denture. There's absolutely no point in making the border like this right now. In fact, it can actually make things worse. Why? Because again, the mucosa can change its configuration, so you need to work only in the area of the attached mucosa. And accordingly, remember that this template you're making will be the prototype for your surgical guide. So you can, without going into details, just follow along with what I'm doing right now. So we draw the border approximately here at the middle of the crest of the upper jaw, with a slight extension into its vestibular part. Notice that I am not drawing the border along the mucobuccal fold. You shouldn't do it that way. Why? Because here, most likely, well, actually, not most likely, we can see that the mucosa was being pulled away here. That is most likely, for example, when the doctor is working with a silicone impression. The silicone material pulls on the mucosal bands. When, for example, scanning was done here, an Optrogate was probably placed in the mouth, and the mucosa was also being pulled away. But in reality, when the patient undergoes a CT scan, and in the vast majority of cases, they do the CT scan somewhere else, and not in your presence, these mucosal bands, which the surgical guide will rest against, can dislodge it, meaning they can cause it to shift out of place. That's why it's best to make the border like this, meaning not pressing against these bands. Nevertheless, you should still leave some space for the vestibular surface as well. And we actually capture the palate quite deeply, that is, the palatal surface, because the palate is our main point of position. So basically, this is more or less the prototype of our future surgical guide. And this is more than enough for alignment, because now let me make the guide. Why is that? Because later, this white surface that you see here, you will align it along this inner contour with the guide you made. So you see, this inner contour is kind of imprinted, and since your model is static, that is, it doesn't bend or flex in space or anything like that, basically. This area is more than enough for alignment, because, let me repeat, there is absolutely no point in making the guide gigantic, covering the entire jaw, and thinking that it's a plate prosthesis. You won't get anything good out of that. Now, after we've created this basic template base, we move on to our usual steps, namely removing everything unnecessary. Well, there isn't really that much to smooth out here. I've just smoothed out a couple of rough protrusions. And now actually comes the most fun part of this whole process. We're going to make special holes. As I've already shown you on this template, maybe the camera will focus again. You can see these dots. These dots are in fact the radiopaque markers. So how do we make them? Let's first talk about how we create them in the software. In the software we do it like this. We select the around window tool. Right now I'm actually sharing with you what could be considered our trade secret. Try to make the diameter of these windows exactly 0.8 millimeters. That works best for us, and you'll soon understand why. We set it to 0, yes, 0.8, and now we need to make, well, about 15 to 20 of these windows. Again, for now, just follow along with what I'm doing. Later, after I finish all this, I'll give you some commentary. Position the template like this on the vestibular side. Now we have this green slider appearing at a slight angle, and we press once, then move this area a bit more perpendicular to ourselves. Press twice, again, more perpendicular, 3, 4, and finally 5. So what happens if you don't position these areas where you're placing these markers perpendicularly? The thing is, this green slider, this green marking of the window, so to speak, it actually shoots through everything you see. Accordingly, if you don't change the orientation of your template in the 3D scene like I was just doing here, here, and here, but instead always create these windows from the same side, then all of them will be oriented in the same direction. And from a technical standpoint, that's not a very effective implementation. That's the first point. And the second point is that if you don't tilt them well, if you place the templates straight down from above like this, you'll end up with extra windows here, which you don't need. That is on the inside, because again, this template, or rather this green slider, pierces through everything in its path perpendicular to your line of sight. So we make 5 of the same holes in a staggered pattern. 2, 3, 4, 5. All right, we've made those holes, and now do the same thing on the palatal side. 1, 2, 3, 4, and some kind of 5th one. Try to place them roughly in a staggered pattern and on different planes. There aren't really any strict rules about the exact distance between them, and there can't be, but still use common sense as your guide. You need to make, say, from 10 to 20 points, spaced roughly equally from each other proportionally across all areas of this template, and accordingly you should end up with something like this. Click next step and take a look at the final result. Well, here are the same mistakes I was talking about. When you create this template in this way, by choosing a not so correct path, you end up with these kinds of junk holes, so to speak. And it's really up to you what to do with them. Okay, and now at this point you simply take this file, then click on the export guide button, and after that export it so you can send it out for printing. Your printer will print out accordingly this kind of template with these holes, each with a diameter of exactly 0.8 millimeters. So I have about 5 minutes left to explain how to make them and what happens with them next. When you receive this kind of model in your laboratory or wherever you print it, maybe in a clinic, what should you do? You need to insert gutta percha points into these holes and seal them on both sides with heat. So if you don't know how to do this, ask your colleague who is a therapist. They definitely know how to do this. So gutta percha point is inserted into this window here and then sealed on both sides. We usually use size 35 gutta percha, which is green, and it fits these windows perfectly. So you really don't need to glue anything in. It holds perfectly well there, even if one of these points suddenly falls out of the template. It's not a big deal because there are between 15 and 20 of them here. That's it. Just to remind you, for alignment, we need at least 3. Well, this is in fact a geometric axiom that there, a plane there through 3 points and so on. That's it. So once again, we export all this for printing, print it out, and then we insert gutta percha points into these holes and heat seal them from both sides. That's all. And then the patient goes and gets a CT scan with all of this, with the whole setup. If you're doing this for the first time, for example, it's better to invite the patient in. First, to understand for yourself how it works, and second, to explain to the patient how they should handle the template. And you fit this template in the oral cavity. You fit it, make sure it doesn't shift anywhere, doesn't dwell. If my fingers are the ridge, the edentulous ridge, then it should look something like this. It doesn't move around. It fits snugly, meaning it doesn't move at all and all that, and so on. Of course, if you press really hard or try to shift it forcefully, there will be some slight play, but you need to keep in mind that during the surgery, you also fit the future surgical template to the Edentulous mucosa and secure it with pins, which will definitely hold it firmly in place. That's why during the CT scan, you explain to the patient or to the radiology technician you're working with, or to your assistant, or you control it yourself, that this template should be pressed either with the opposing teeth, or someone holds it in place with the tongue, or there's a special bite block for the CT scan, meaning on the CT machines themselves, or it could be bite blocks, or for example, a silicone bite block that you make yourself from silicone and things like that. In other words, this thing is needed simply to hold the template in place for about 15 seconds while the CT scan is being taken. Be sure to save this 3D file in your project, because first we'll need it later at the next stage when we directly align one with the other and model the surgical guide. So what else is there to say about this? What else can I say about this? Yes. You don't need to scan this template again. After the CT scan, you can just throw it away. And this is very good from a logistic standpoint and really makes the process much easier. And overall, aligning using these tunnels is, yes, a bit complicated, but it turns out to be much more accurate. Believe me, we've tried different methods, and in fact, for good reason. Now, well, for about 5 years already, we've been doing every Edentulous jaw case using this method. So, dear friends, I hope you found this interesting. In the next lesson, I will definitely explain how to work with this and how to make a surgical guide directly using this thing and how to align everything together. So please like, share this video and spread the knowledge. See you next time. Bye-bye. And all the most interesting things will be discussed in the next lesson.